Hello aspirants. So today we are going to look at some of the important topics related to space science and technology. So nowadays you would be hearing about different space launch vehicles or ISRO's space launch vehicles. So you would be hearing about PSLV and GSLV. You would have also heard about that ISRO has started last year what is known as a small satellite launch vehicle. So what is this small satellite launch vehicle? What is this PSLV? What is this GSLV? And how do they work? So we will try to understand that in this small video. So in order to understand how do launch vehicles work, we have to understand what is the principle behind these rockets or what is the working mechanism of that. So let us just try to understand that. So if I say that a launch vehicle or a rocket, if a launch vehicle or a rocket is just like a balloon. So if I take a balloon, if this is a balloon, if we take a balloon, then let us say we have filled the balloon with air, and what we are doing now is that we are leaving this end open. So after filling the balloon with the air, what we are doing is that we are leaving this end of the balloon open. So what will happen in this case? So gases or air that has been filled here will start moving out. Now since the air is moving out, the balloon will also move but in opposite direction. So this is very famously known as Newton's third law of motion. Why it is called as Newton's third law of motion? Newton's third law of motion says that every action produces equal and opposite reaction. So in this case, when we are releasing this end, the air is moving out in this direction, so it will create an opposite reaction in the opposite direction. So the balloon will move in the opposite direction. You would have experienced this in your childhoods also, or you would have observed this. So rockets also use these principles. So what do we have to do to send rocket to space? We have to, if we have to send rocket into space, we need to thrust out some gases. So you would have observed that we thrust out some gases from the rocket, and those gases, because they are thrusted out in one direction, it gets a thrust in opposite direction. Now the question remains that how do we produce those hot exhaust gases? So in order to do that, we use a fuel and we use an oxidizer. So why do we need to use fuel and an oxidizer? Why cannot we take oxygen from atmosphere? So any rocket will leave the Earth's atmosphere. After 100 kilometers, it will not get the supply of oxygen. So rocket has to carry a fuel and something to burn that fuel, that is the oxidizer. So the general design is that it has chambers. It has chambers for fuel and the oxidizer. So there is this fuel chamber, then there is this oxidizer chamber, and let us say this is a launch vehicle which is having only one stage. So by one stage it can send a satellite here. So let us say the satellite is kept here in the upper portion. So the satellite, that is the payload, is kept here. Now through pipes will bring in the fuel and the oxidizer using some pumps. So those pumps will help to bring the fuel and the oxidizer, and what do we need to do is we need to burn it in a combustion chamber. So when we burn in this combustion chamber, we'll burn the exhaust gases in the combustion chamber, and because the fuel and the oxidizer, they combine or they burn, and when they burn they will produce a lot of hot exhaust gases. So when they produce a lot of hot exhaust gases, we force them out through these exhaust nozzles. So what is happening here? We have been able to produce a lot of hot exhaust gases in the combustion chamber, and then we are able to force it out. So what will happen, because the hot gases are moving out in this direction, it will produce an equal and opposite reaction in the opposite direction. So we get a thrust in this direction. So this is how a rocket moves, and the rocket has to move at very high velocity. So it has to move or reach to what is known as escape velocity. What is escape velocity? Escape velocity is the velocity needed to escape the gravity of a particular object. For Earth, that escape velocity is around 11.2 kilometers per second. So if any object can travel at 11.2 kilometers per second, then it can escape the gravity of Earth. For different planets, the escape velocity would be different. So now let us see what is this launch vehicle of India, or what are the different launch vehicles of India. So India started its journey with respect to launch vehicles way back in 1970s, and since then we have developed some of the most powerful launch vehicles. And in the most powerful launch vehicles, we are also using what is known as cryogenic engine. So let us just here only see what is a cryogenic engine, then we will see the evolution of the Indian launch vehicle. So in a cryogenic engine, the difference lies in the state of the fuel. So when you say cryogenic, or when we say cryogenic, it is derived from a Greek word, cryos. This is derived from a Greek word meaning cryos, or cryos means frost, and genic means to produce. So when you say cryogenic, it means that all the sciences or all the products and processes which are carried out at very low temperatures. So we have a cut threshold, or we have a cutoff, that anything which is done below minus 150 degrees Celsius, all the processes carried out or all the physics carried out below minus 150 degrees Celsius is known as cryostate, or this is known as the cryogenic phenomena. So what is happening at cryogenic? In a rocket, how are we using this cryogenic engine, or what is this happening in the rocket? So when we go for cryostate, or when we go for cryogenic engine, so in that engine, let us say if we are using hydrogen as a fuel. So if conventionally if we are using hydrogen as a fuel, and in what will happen when we go at cryostate? Cryostate, it means that if we cool down to minus 253 degrees Celsius, what happens? So gaseous hydrogen converts into liquid hydrogen. Gaseous hydrogen will now convert into liquid hydrogen. Hydrogen is the lightest gas in this universe, and when we make it liquid, we see that the volume drastically reduces. So when we decrease the temperature to minus 253 degrees Celsius, it is said that the volume decreases to more than 600 times. So do you now realize that in this same space, we have packed more hydrogen molecules, and what is happening essentially is that we have drastically increased the energy density of the fuel, and because of that, when we burn, we get a lot of hot exhaust gases. Because we are getting a lot of hot exhaust gases, we are able to produce more thrust than conventional engine. So here we take not only the fuel at cryostate, but we also take the oxygen or the oxidizer also at cryostate. So if we cool down oxygen to minus 180 degrees Celsius, it also becomes liquid oxygen. So what we are doing is that we are taking both the fuel and the oxidizer at cryostate, and at cryostate they are becoming liquefied, or their volume is drastically decreasing, or their energy density is drastically increasing, and that is why when they combine and when they burn, they produce lot of hot exhaust gases, and that is thrusted out, so they are able to produce lot of thrust. So that is the biggest advantage of cryogenic. And how do we do that cryogenic? In order to store fuel at such low temperatures, we need some other mechanisms, or what we do is that we need some insulations. So we will insulate these chambers through some material. We will insulate both the oxidizer and the fuel chamber. So we will have them insulated so that the heat which is being generated here does not reach here or does not affect the fuel or the this oxidizer chamber. And we also have some vents. Why do we have vents in these chambers? It is because if, let us say, this gas, this liquid, if it wants to convert into gas, so if it starts to get converting into gas, it will increase the pressure inside the chamber. So how do we avoid that? So if there is a drastic increase in the pressure in the chambers could burst out. So one way or one mechanism to deal with this situation is to provide vents. So just as in a pressure cookers we have that safety valve or some vents to pass out the excess pressure, similarly we have some vents so that the excess pressure inside these chambers can be passed out. So this is how the rocket engine is designed, and this is how we have developed the cryogenic engine. Yes, cryogenic engine is a very, very difficult technology, and it took more than 20 years for India to develop it indigenously. So India, yes, it has developed it indigenously, and why it took so much time? Because it was getting support from Russia, but because of MTCR, that is Missile Technology Control Regime, Russia was not able to help India, and so India had to develop it indigenously, but it took long time. But now we have developed this cryogenic engine, and we are using this cryogenic engine in our GSLV. So let us now try to understand how the launch vehicles of India has evolved. So the journey of launch vehicles of India started way back in 1970s. So India started its first launch vehicle, that is known as the satellite launch vehicle. Satellite launch vehicle way back in 1970s, and in 1970 when this program started, the payload capacity, when we say payload capacity, what we mean by that, it is that what is the capacity or what is the weight of the satellite or the object that it can carry to space. So the payload capacity was quite limited. So the payload capacity was only 40 kgs, in LEO. 40 kgs in LEO. LEO means low Earth orbit. Low Earth orbit is which type of orbit? So any orbit which is less than 1000 kilometers and up to 160 kilometers. So any orbit between 160 and your 1000 kilometers is considered to be low Earth orbit. So using SLV, you could send only satellites up to 40 kgs weight. So there was a need felt that we should increase the capacity. So India came up with what is known as ASLV. ASLV. This is known as augmented satellite launch vehicle. And its payload capacity was better than this, but was not still too very high. So its payload capacity was 150 kg in LEO. So this started in the 1980s, but again the need was felt that we need to have more launching or this payload capacity. So India started developing PSLV or Polar Satellite Launch Vehicle. This Polar Satellite Launch Vehicle, it conducted its first successful flight. ISRO conducted the first successful flight in 1994, and since then it has become the workhorse of ISRO. So it has sent more than 200 foreign satellites, it has sent more than 50 Indian satellites. And the uniqueness about PSLV is that it was the first launch vehicle of India which has used liquid engines. liquid engines. So in the SLV and ASLV we were using only solid engines, or we were using only the solid fuel. So only in PSLV we first started using liquid engines, and since then we have been able to increase the capacity of the launch vehicle to a higher level. So what is the payload capacity of this? The payload capacity of this is 1700 kgs in LEO. 1700 kgs in LEO. And this PSLV, we will just take a note that this ASLV and SLV are out of commission, that is, we are not using this now. We are only using PSLV and GSLV. So this PSLV has 4 stages. PSLV has 4 stages. So in PSLV we see that there are 4 stages. So the first stage is solid, second stage is liquid, then third stage is again solid, fourth stage is again liquid, and it also has some booster rockets that helps during the initial launch or initial lift. So PSLV has 4 stages, and you will see that it also is using liquid engines. So PSLV has emerged to be very efficient launch vehicle. So we have been able to send some of the marquee missions such as the Chandrayaan 1 and Mangalyaan. So we have used this PSLV to its maximum capacity. But still the payload capacity, we wanted that we could be able to send some of the heaviest satellites using our own launch vehicles. So before GSLV, what we were doing is that the heaviest telecommunication satellites, that is the GSAT, we used to deploy ESA's or European Space Agency's Ariane vehicle. So we wanted that we should be able to develop the capacity to send the GSATs also. So for that, India started what is known as GSLV. This is known as geosynchronous launch vehicle. Geosynchronous launch vehicle is the launch vehicle which has the maximum capacity of all the launch vehicles which India has. GSLV has the maximum capacity. It has the payload capacity of 10,000 kg in LEO. And why does this have that much capacity? Essentially because it uses solid engine, then liquid engine, and in the final stage it uses cryogenic engine. So it has 3 stages. It has solid, liquid, and this is known as cryogenic upper stage. It also uses some booster rockets in the initial lift. And because of the use of the cryogenic engine, it has this high payload capacity. So with this we are able to send some of the heaviest telecommunication satellites to some of the highest orbits also. So this has been the journey of India's. But India realized that in order to send some of the small satellites for research purposes, satellites for commercial purposes, so we need to develop some different kind of launch vehicle. So last year ISRO started what is known as small satellite launch vehicle. So other than this, India has developed what is known as small satellite launch vehicle. So what is the uniqueness about this small satellite launch vehicle? That it will cater to the on-demand launch of small satellites. So let us say if you have designed a satellite, or if some institution has designed a satellite, and if they want to send a satellite to space, then they can go to ISRO, and ISRO can very quickly, within few days, send your satellite. So if you take the conventional PSLV or GSLV, and if you go and ask for their services, it will take around 70 days to configure the conventional launch vehicles. But if you talk about SSLV, the configuration time is just 72 hours. The configuration time is just 72 hours. That is why India or ISRO believes that by having this type of launch vehicle, we can increase our market share in the small satellite launch service market. So some of the technical features of SSLV is that it is not using any liquid engine, it is not using cryogenic engine, it is using only solid engines, and it has 3 stages. So it has 3 stages, all solid, and the payload capacity of this is not very high, but that is not required for sending small satellites. So the payload capacity is 500 kg in, let us say, 500 kilometer LEO. Or if we want to go to a higher orbit, let us say 300 kg to the sun synchronous orbit. Sun synchronous orbit means more than 500 to 800 kilometer. So we are utilizing this to send some of the small satellites. And the best part is that since the configuration time is less, the significance is that we have reduced drastically the turnaround time. What is this turnaround time? Turnaround time is the time from initiation of a process to completion of the process. So the turnaround time has drastically reduced, and it is also very cost efficient. So per kg launch cost is also very less. So if the turnaround time is less, so the production in the ancillary industries will also be higher. So we will be generating jobs also. So this is the advantage of the small satellite. India will be able to increase its market share in the launch vehicle. So it will boost our GDP also. So this is the advantage of having SSLV. SSLV was in news because the first launch was not successful, but the second launch has been successful. The first launch was not successful. There is a simple reason is that, so what had happened in the first launch, that ISRO wanted to send a satellite in a circular orbit, of around, let us say, in a circular orbit of around 380 kilometers radius. But by mistake, it was not able to send or course correct in this type of orbit, but somehow it sent it in an elliptical orbit having this longer length as 380 kilometer and this length around 70 kilometers. So what was the problem with this? That our atmosphere, that thickness of our atmosphere is around 100 kilometers. So this small satellite was again entered into Earth's atmosphere and it burnt out. So that was the reason for its failure. So the second launch was quite successful, and we'll be seeing more such launches using SSLV. Now in launch vehicles, you would have heard about Falcon's SpaceX or SpaceX Falcon. SpaceX Falcon. Now what is this Falcon? So this Falcon is world's first completely reusable orbital class launch vehicle. So why it is considered to be reusable? So if you see the launch vehicles, these launch vehicles, the different portions of the launch vehicles. So if you consider this launch vehicle, so what will happen? That the first stage will fire, that will provide the lift. Then the booster rockets are also fired. So simultaneously first stage and booster stage is fired. So after some time, after it has reached to some height, the booster will fall off. The first stage will fall off, and they fall off generally in the ocean. The second stage will then fall off, third stage, then the fourth stage, then the satellite reaches the space. So what is essentially happening, that the different parts of the rockets, some of the most important parts, some of the most costliest part of the rocket is essentially lost in the oceans after the launch. So the idea of SpaceX Falcon is that why do we lose those parts? Why cannot we bring them back or land them at a specific position so that we can reuse it, we can refly it? So the idea of Falcon is that we should be able to reuse and refly the major parts of the rocket. Why? Because if we want cheaper space travel, the costliest part should be reflown again and again. So that is why Falcon is having that feat, that it uses most of its parts to fly again. So Falcon, the advantage of Falcon is also that its payload capacity is very high. If you look at Falcon Heavy, the heaviest launch vehicle which SpaceX has, so it has the payload capacity of more than 6 times this. So it has payload capacity of around 64,000 kgs in LEO. And if you look at cost wise also, yes, it is costly than GSLV, but if you look at the per kg launch cost of SpaceX, that is also cheaper than GSLV. So we still have a long way to go. ISRO is also trying to develop some of the reusable launch vehicle. So it is developing what is known as the RLVTD. RLVTD means reusable launch vehicle technology demonstrator. Reusable launch vehicle technology demonstrator. It means that we are testing it. So we have developed this platform to check some of the critical technologies to develop our own or indigenous reusable launch vehicle. So this was a short video with respect to the different launch vehicles, the engines, the principle of a rocket, and hope to see you soon again. So thank you for that.